Hello everyone, my name is Ken Lee, and in this video, I'm going to talk to you about DevSecOps. Well, I introduce you to DevOps and how to build, deploy, and run applications more securely across the hybrid cloud, leveraging Red Hat Advanced Cluster Security and Openshift. So, what is DevSecOps and why in the world is it important? And how does it affect your business and applications? Well, let's start with DevOps and by breaking down the types of group personas that are usually involved in a DevOps culture. That breakdown usually presents itself to two general groups, app development teams and dev operations teams. Now, I want you to keep in mind, this is really a basic simplification. Organizations can be complex, and also not to mention to all the challenges and obstacles you face implementing DevOps, because let's face it, DevOps first involves cultural change and acceptance, and then change in practices and process. And those things take time. So given the two existing groups, we add a third additional group, the security team. And ultimately, we integrate the security team's culture into our DevOps culture. Together, these three teams and their cultural practices together makes up a DevSecOps culture and practice. So typically in past practices, security would be something that would come into play usually after the fact. And what I mean by after the fact is that it would come much later with respect to the software development process. Now, fast forward to today, where security breaches are now just a part of daily life in the local and national news, ranging from ransomware attacks, data theft, identity theft, you name it. These things, they happen to individuals, small businesses, and of course the large ones too. So what is it that we can do to become proactive in preventing and or staving off these kinds of attacks into our organization? We start taking security a step further. We do this by shifting security to the left in our software development lifecycle. And what that means is simply introducing and integrating security early in each stage of the software development lifecycle, so that ultimately security doesn't just become one group's responsibility, it becomes everybody's responsibility. And so what do those types of behaviors look like once you adopt this DevSecOps culture? One for being, security teams are brought into conversations early and often. Teams actively communicate to address security at the forefront. And then teams start using appropriate tools to aid in security management. And then also infrastructure decisions are made to be cognizant to existing and future security concerns. And then also applications are designed with security in mind. So here's another view of the software development lifecycle, but reflective of the processes of the dev and ops teams. Where does security fit in here? We mentioned about shifting left in the previous slide and some of the behaviors involved. And so security is now involved and automated at every facet and step of the software development lifecycle. An example of this might include a procedure called image scanning, which involves scanning for vulnerabilities in your container images across build, testing, deployment, and runtime to make sure that what you are introducing into your security is secure in DevOps processes. We'll discuss in more detail on what kinds of DevSecOps strategies are available on a pipeline, as well as illustrate some of these strategies in our demonstration. As much as anything else, the move to DevSecOps is about getting humans out of the middle of processes that are simply better handled by software. Once you get a human out of the equation, you get rid of errors caused by mistakes, typos, jumping ahead of instructions, or any number of other problems that humans are prone to. This is not to say that all errors are caused by humans and that automation removes all errors. After all, if there are errors in the instructions provided to an automation system, you will just keep having those softwares make that same mistake over and over. Along with automation comes consistency, of course. You develop a plan you want your orchestration system to take care of for you. You test it to make sure it is doing what you expect. And then you let your orchestration system keep taking care of it over and over and over, exactly the same way every time until you change what you want done. Fortunately, this is where a Kubernetes platform like Openshift excels. You see, DevSecOps allows you to approach security continuously and realistically across the application and infrastructure life cycles. These cycles are divided into different phases, such as designing, building, running, managing, and adapting to new changes, and then rinsing and repeating the process again and continuously. That process should never end. You should not grow tired of it, because the majority of it should be automated, leaving you to do what you do best, whatever that may be. The point is security must be continuous and holistic. At Red Hat, we're able to deliver continuous security for containers in Kubernetes by extending the security layer through Red Hat Advanced Cluster Security. We'll call it ACS for short going forward. It provides a layer of protection at build time, during deployments, and at runtime. It does this through things like vulnerability analysis, app configuration analysis, compliance assessments, risk profiling, as well as runtime threat detection and incident responses. And that's just to name a few of the ways ACS extends the security layer. So with ACS, we have a means for securing the supply chain with scanning facilities as well as the policy management facilities. What this means is that we can integrate these scanning utilities into our delivery pipelines steps, and we can add policies which can be enforced across build, deployment, and runtime. And what I mean by policy enforcement is that you can do things like fail or allow builds. You can prevent or allow deployments. You can literally stop a pod while it's running because it violated a policy. This can be done by enforcing a policy within ACS's policy manager. Moving on to the next piece here, with ACS's cloud and security posture management facilities, you have insights into vulnerability and compliance, which allows you to identify threats and remediate configurations and deployments. This could be anything from seeing violations that are not being properly enforced or detecting vulnerabilities on images running on existing deployments, remediating compliance policy violations across one or more clusters. Yes, across one or more clusters, you can manage policy across multiple clusters and have those clusters report to a central instance of ACS accordingly. Lastly, ACS allows you to secure workloads by allowing you to maintain and enforce the zero trust execution approach to workload protection. We have a dashboard which allows you to see the network traffic of your deployments. You can see what's coming in as well as from who, what's going out as well as to where, who's receiving what, and you can fine-tune that traffic for exceptions and or allowances to access resources, hence allowing you to implement zero trust as you see fit. So we are staking our claim to say that we are the first Kubernetes native security platform. So what exactly is a Kubernetes native security? Simply put, it's security that operates at the Kubernetes layer. It derives context from the Kubernetes and pushes policy into Kubernetes for Kubernetes to enforce. Typically, you may have seen similar types of policy enforcement taken at a container-centric approach to enforcing security, but that is container-centric and not Kubernetes cluster-centric. So given that explanation, and clearly depicted here are the various ways to integrate with Red Hat Advanced Cluster Security. Everything from image scanning, container registries, CI/CD tools, notification mechanisms, and event management. You're not short of options. There's generally something for everyone. What I do want to stress is the ability to manage and enforce policy across multiple clusters. And that means across multiple distributions of Kubernetes, not just Openshift. So let's talk about pipeline strategy. Each of you may be at any particular stage of progress in your pipeline strategy. And that's totally okay. For the ones that are starting off or are very new to the cultural paradigms and practices brought upon by DevSecOps, I have two unsolicited pieces of advice for you. First, start small and build your way up. Second, know that Rome wasn't built in a day. So don't expect DevSecOps to take off to the races in a single leap and bound at your organization. It's going to take time. It's going to take your organization and teams to really communicate with each other and come to terms with what's working, what's not working well, and what you need to change. Ultimately, you've got to start somewhere and strategize your way through.
So as I was saying, you start small. This is a very basic DevOps pipeline. There is no security inside. It's bare bones. We build and unit test our app. We containerize and push its image to a container registry, and then we deploy to our cluster. Pretty simple, easy peasy. As a matter of fact, it's crazy simple. Let me show you. So let's go ahead and create a project in Openshift. Go to projects, go to create project, and we're going to call this project demo app 001. So we'll go ahead and let that project create. And now I'm going to switch view types in Openshift and switch over from administrator view to developer view. And then I'm going to import a Java project from an existing Git repository. So let's go ahead and do that. So let's switch over to developer view, skip the tour, and then let's go ahead and click add project. and then we'll go ahead and import our project from Git. And in this case, there's an existing project that I have. This here is probably a familiar project. It's the Spring Boot Pet Clinic application. We're going to import this project into our Openshift project. So we'll go ahead and grab the Git URL for this project. So we'll copy that, and then we'll paste that into our box up here to import from. So we will select the Java Builder image in the latest version of it, and all this tells me is how I want to build my container. So let's go ahead and select a builder image, and we're going to select Java, and then we'll select the latest version. Okay, so selecting a builder image is another way of telling Openshift that I want to leverage something called source to image. So what source to image is just that. It's going to build my application to a Java artifact. In this case, it's going to build a jar artifact from my Spring Boot code, and then once it's done with that, it's going to containerize the artifact to a container image, which will then be deployed, exposed through service, and then exposed through a public route. So if we scroll down here, let's start filling all these values here. So let's give our application name Spring Pet Clinic. And we'll give it the same for the name too as well. And then we're going to select deployment for our resource. And then let's go ahead and click this add pipeline button. So here's where things start getting a little interesting. I had mentioned that when starting with DevOps to start off small. So this checkbox here, add pipeline, does just that. It creates for us, and if I expand this, it creates for us a small pipeline that we can build onto. Let's go ahead and check that and then create the project. So what's going on here at this moment is that the code is being pulled in, compiled, and an image will be built and then deployed. Now we can get a clear picture of this by looking at the pipeline that was dynamically generated and deployed. So if we go to pipelines, we see that we've got a running pipeline right here, and if we actually click on the pipeline details and go to pipeline run, and then click on the details of that run, we'll see the various pipeline stages that are in progress right now. So we can actually take a look at the details of those pipeline stages by clicking on logs. And clearly we see that the first one, fetch repository executed, and right now we're in the middle of a build. So as this builds out, the next stages will also execute too as well. And so continuing back where we left off from, we clearly see that the build stage is completed, as well as another stage has completed too as well, which is the deployment stage. Now, the deployment stage, what it did is went ahead and deployed the application, of course. So if we jump back to our topology, we can get a little bit more information about that. Let's go ahead and click on the artifact here, Spring Pet Clinic artifact, and we clearly see that the pod has been deployed, it's been exposed through a surface, and then the service has been exposed through a route, right? So if we go and click on that route, of course, we can go ahead and see that our Spring Pet Clinic application has now been deployed. Now, let's take a step back. What you just saw was actually made possible by Kubernetes operators found within our Kubernetes operator marketplace called the Operator Hub. So if we go back and we take a look at what that Operator Hub looks like, here you see a various plethora of different types of operators that you can choose, right? And so in our case, if we actually click on the installed operators, we see that the operators that we've chosen today in our demonstration, we leverage three different operators. First is the Openshift Pipelines operator, which is the downstream release of Tecton Pipelines operator supported by Red Hat. So the pipeline that was generated when I imported our project from Git earlier is solely due to this operator. The next operator to mention here is the Openshift GitOps operator, which is the downstream release of the ArgoCD operator supported by Red Hat. I'm leveraging this operator to synchronize my Kubernetes manifests across releases, which makes the Git repository the central point of truth for your deployments, and thereby in this case, effectively creating a workflow for release automation. And finally is Red Hat's advanced cluster security for Kubernetes operator, formerly StackRox, which of course is also supported by Red Hat. This operator will be solely responsible for employing Kubernetes native security across their registered Kubernetes clusters. Its job is to deploy, monitor, and enforce policies at build time, deploy time, and runtime for our registered clusters. So coming back to our basic pipeline, we're going to want to add some additional stages to this pipeline to build upon our strategy. That being said, here we add a few more stages to our pipeline, which includes things like quality gate analysis for leveraging Sonar, an artifact repository leveraging Nexus, performance testing after deployment via Gatling, and even something to help automate semantic versioning. While these aren't supported by Red Hat, this goes to show the capabilities that are available to add in our DevOps strategy. And because we're an open source company, we also have no shortage of contributions back to the community. One of those contributions that we provided is called the GitOps catalog, provided by the Red Hat community practice. And what it is a catalog of various operators in Kubernetes customized deployment manifests that you can use to supplement your infrastructure and platform. So for example, if you want to go ahead and deploy Nexus operator, or maybe you want to deploy Sonar Cube for that matter, we've got those components available within this catalog as well as a bunch of others. Now, this catalog isn't supported by Red Hat, but the point to illustrate here is that you have a lot of flexibility as to where you want to integrate into the platform. In this case, quality gate analysis and artifact repository may be one of those things. But maybe you're interested in securing your secrets. Well, there's also a sealed secrets operator to help you with that too. Or maybe you want to, up the ante and leverage an enterprise supported vendor for secrets management, such as CyberArk's Conjur or HashiCorp Vault, which is fine too as well. I mean, Red Hat has a vast enterprise partner ecosystem to boot to as well. So moving along here, let's change things up a bit more and revamp our deployment release strategy. Enter GitOps. GitOps essentially means that your deployments are in direct alignment and perfectly represented by what's in your Git repository. And that's because your Git repository is now a source of truth for your deployments. Whatever is in your Git repository is also what is deployed. Now, this paradigm works pretty well with Kubernetes, since Kubernetes does deployment manifests really well in the form of YAML files. And of course, those deployment manifests can be checked in and versioned. So take for example the Pet Clinic application repo I showed you earlier. This would be an example of an application repo where you house all of your application code, which ultimately is used to build and containerize a deployable artifact into a container image. Now there's also another repo which complements the application as a repository for Kubernetes manifest files. Here we see it named as Spring Pet Clinic Config, which houses our Kubernetes deployment manifests. When we drill in to this repo, we see that it houses the deployment manifests for various different environments, such as dev and stage, and any other environment that you choose to have in your deployment infrastructure. Now, drilling back out into our app directory, we see that it also houses Kubernetes manifests such as deployments, routes, services, and customized deployment manifests. So, what exactly is the purpose of these manifests? Well, in short, this repository represents the source of truth for your deployment environments. When you modify any facet of these manifests, they become a catalyst for the respective deployments as a deployment trigger. Now, what gets triggered? In this case, a synchronization of these deployment manifests into your Kubernetes cluster. These manifests are reapplied into your Kubernetes cluster effectively as an updated deployment into your environment. Now, let's go back to our slide. I'll walk you through this explanation in a bit more detail. So here in this diagram, looking at the continuous integration block, we've replaced the previous deploy stage with a different stage that updates the manifest repository that we just looked at. Here we call the stage update deployment configuration repository. More specifically, the deployment manifests will get updated by the CI pipeline by updating the Kubernetes deployment manifest with a new container image that was built and pushed in the previous pipeline stage. In other words, you've got a pipeline which will modify the contents of a Git repository, this being the repo which houses all of the necessary deployment manifests. So once the update deployment configuration repo stage is executed, that will cause our GitOps workflow here in the continuous delivery block down on the bottom here, that will trigger, thereby launching off our continuous delivery cycle. Now let's take a look at how that happens. To the left side, we see a listing of two different pipelines. One is for unit testing, building and pushing our artifacts and images, which we named the Pet Clinic Build Dev Pipeline. The purpose of this pipeline is to execute on continuous integration. And then the other pipeline for deployment, which we named Pet Clinic Deploy Dev, in which its purpose is to execute on continuous delivery. So let's go ahead and trigger build by changing and pushing some application code. For brevity, we're going to trigger this build by directly modifying code in the repository. Typically, you just commit and push using your Git SCM tool. So let's go ahead and do that. And so now that I've made that change, our pipeline is kicking off, and we'll see a notification of that pipeline starting when looking at the pipeline task status, right? And so now that our build pipeline has started and is in progress, let's go ahead and drill down into the details of that pipeline. So here is our continuous integration pipeline. As it runs, it will pull our source, unit test it, build and push to an artifact repository, build an image and push it to an image registry, and then it'll update a set of Kubernetes deployment manifests. In this case, the Spring Pet Clinic code config repo, and it will do this at the last stage of the pipeline. Eventually, when the pipeline reaches the last stage here, as it updates our deployment manifest and pushes those changes back out to the Pet Clinic config repo, that push will trigger another pipeline. In this case, it'll trigger our deployment pipeline, which will deploy our application to the cluster, which also takes care of the continuous delivery aspect of our application. On the right side of the screen, we have our continuous delivery pipeline, which has been triggered by a change to our deployment manifest repository. As the pipeline progresses, it invokes our GitOps software ArgoCD, shown on the left side of the screen, to synchronize our updated manifest by deploying the latest manifest to our Kubernetes cluster. And so what you see in ArgoCD are applications, which in this case represent our deployed applications to our dev and stage environments. When we drill down into one of our applications, for example, the Pet Clinic application in our dev environment, we see the following details about the deployment. Each block here is an illustration of a manifest type deployed in our Kubernetes Openshift environment. Everything from a service, deployment, a route, our replica sets, and then our pods. So I want to stress here that these are all real-time representations of what's deployed to our cluster based on the manifests that are stored in the respective Git repo. This is the essence of what GitOps is, as the current state of what's in our Git repo is reflected in our deployment in our Kubernetes cluster. So we've effectively automated the delivery of our application, which is a form of continuous delivery. Let's zoom back out to our two pipelines, as I'd like to illustrate this point better. So on the left, we have our continuous integration pipeline, and then on our right is our continuous delivery pipeline. They work very closely with each other. When this update stage executes in our CI pipeline, it triggers our CD pipeline. You've seen this before, as I've shown it to you in our slide deck earlier. Let's jump back to the slide deck. So we just walked through continuous delivery via GitOps, as well as rolling back to previous deployments. You could probably take this release automation strategy a little further by leveraging concepts of blue-green or canary deployments. So we are now at the final stretch. Let us move on to the final evolution of our pipeline, security. Now, perhaps some of you might be thinking, wait a second, I thought security was supposed to be brought in early. Is that not what shifting left is? And why are we seeing security brought in so late here? Well, what we're showing here is an evolution of a pipeline starting off with a DevOps strategy and then segueing into a DevSecOps strategy. Ideally, you'd start from the beginning with a DevSecOps strategy, meaning you'd have your security team integrated with the rest of your teams, and then integrated into your agile project plans, Kanban boards, and daily scrums, as well as other project and team rituals. So, shifting focus to the additional stages brought in, I want you to focus on the new stages up on the top for Advanced Cluster Security for Kubernetes, ACS for short. Here we see 3 stages pertinent to the security of our pipeline build and deployment processes. These stages do the work of checking for policy compliance. Depending on how a policy is enforced, it may just be a passive warning, or the executing stage could cause your entire pipeline to stop because of an enforced policy violation. The first stage we see as the image scan. What that will do is scan our image for its components, as well as any vulnerabilities, and generate a report which we can review. You might have heard of or are familiar with other image scanners such as Claire, Trivy, or Schnick. There are many more out there like it. The next stage is for an image check. This scan does a deep dive into an image and checks for vulnerabilities and policies that are being violated at build time. If you enforce a policy within ACS and this stage detects a violation, the stage will fail until the violation is resolved or until the policy is modified to allow the violation. The last stage is for a deployment manifest check. This scan checks build time and deploy time violations of your security policies in YAML deployment files. Some examples of that might be if limit requests on CPU or memory are violated, or perhaps an image is referenced in your deployment YAML, and maybe that image has been flagged for policy violations. So let's jump on over to our pipeline in Openshift to see about these scans and checks in more detail. What we've got here is a representation of the DevSecOps pipeline that we were just looking at a moment ago. To the left is our CI pipeline, and then to our right is our CD pipeline. The stages that we're interested in looking at are located in the CI pipeline, which are the image scan, the image check, and the deploy check pipeline stages. So let us navigate to the pipeline run section to view the previous runs of this pipeline. When we look at the pipeline runs, we see that there's already been a run of the pipeline, and we see that it has failed. So let's check to see why by clicking on it. So here we see that among the security related stages, the image check stage has failed and has therefore halted the pipeline. So if we look at the summary details down on the lower right of the screen, it gives information about the point of failure as a bit of a log snippet that might tell us about the failure. Here it's telling us that a security policy has been enforced at build time and has been violated and has therefore caused the rest of the pipeline to halt. So let's delve further and see why the image check stage failed by checking out the logs. To the left of the stage are the pipeline stages, and we're interested in the image check pipeline, which we've already got selected. So let's examine this log a little further. So clearly there were some violations, and at least one of those violations had enforcement turned on, which caused this build to fail. If we look at these violations here, we see that this policy is what caused the build to fail. If we look at further policies that failed, we see that another policy, which was violated, did not cause the build to fail. That's because it's not being enforced. So I want to grab the name of the policy that's causing this failure in this error log here, and I'm going to copy this to the clipboard.
So because that's the policy that's giving us trouble, we want to go ahead and troubleshoot it and see about how to make it stop giving us trouble. And to do that, we need to jump to where this policy is defined and enforced at, which in this case is through ACS. So let's go to the ACS dashboard. So this is the main ACS dashboard. There's a lot going on here in summary. What I'd like to show you is the policy editor. So let's jump over to that. As you can see here, we have policies that pertain to different stages in the life cycle of the policy enforcement and that have varying degrees of severity, and also anything that's got a green dot is currently enabled. So let's go ahead and search for the policy that we want to edit. So I'm going to copy from our clipboard. And there we have our search result. And let's go ahead and click on this policy that's giving us trouble, and then we're going to go ahead and edit it. Next, next, and next. So in this portion of the policy editor, we're able to select at what point we want to enforce this policy. Those points of enforcement are build time, deploy time, and run time. Currently, we've got the policy build time policy enforcement turned on. So we'll just switch that to off, and then we'll save the policy. And now that our policy is saved, we can go back and rerun our pipeline since the enforcement of this policy is being suppressed. So let's go ahead and do that. And here we'll click to rerun the pipeline. And so now the pipeline is rerunning. And so let's click on that and observe the run of the pipeline. And so because I made a policy change in ACS, our pipeline was able to successfully complete, whereas it had failed before because of the build time policy enforcement. Let's switch gears and jump on over to the clusters view in ACS, where I'll show you how to enforce security across hybrid clusters. So starting back from the main dashboard in ACS, let's go to our clusters view. We'll do that by clicking on platform configuration and then clusters. And so in this view here gives us a listing of clusters being managed by ACS. The first cluster in this list is our development cluster, which is a cluster that we've been working in this whole time. And then the second cluster in this list is a separate cluster which was imported earlier, where its security is being managed by this instance of ACS. And so because of this, at this point, we are within the realm of hybridized cluster security management. And so henceforth, we're able to secure our applications across hybrid environments. We're able to apply and enforce security policy across the hybrid cloud. So let's jump in and see what this looks like. So let's go ahead and jump into the policy section of ACS. So we'll go ahead and click on System Policies. And what we're going to do is create a new policy and enforce that policy at deploy time. So we'll go ahead and click on New Policy, and then we'll fill in the blanks here. So let's start off by giving this policy a name. We'll call this policy No Parking Allowed. And let's assign it a high severity. And then we'll pick a life cycle stage, in this case deploy time. And then let's give it a description. No parking in this namespace. And then the rationale is that it's because it's for a demo. And then its remediation is to turn off enforcement or deploy to another namespace. And then we're going to assign it a category. So in this case, we'll select privileges. Okay. So let's go ahead and click on Next. And here we get to define the policy criteria.
So in this case, I want to create a policy which triggers a violation when a pod resource attempts to deploy to a specific namespace. In this case, we'll call that namespace no parking. So let's go ahead and pick that criteria. So we'll add a new condition, and I believe the namespace criteria is in the deployment metadata. So we'll drag namespace, and then we'll assign the namespace to the value of no parking. And so here, we'll go ahead and enable deploy time enforcement of this policy. And then we'll save it. And after doing so, the policy will be active. So what we've done so far is create a policy which will be active and enforced at deploy time. Any attempt to deploy artifacts into the no parking namespace will result in the deployment being blocked. Let's go ahead and validate this now by attempting to deploy a workload into the no parking namespace in both clusters. So on the right side of the screen, we have two terminals, one for each cluster registered in ACS. Running the following command gives us some information pertaining to the cluster in the namespace that we're working in. In both clusters, we are currently in the no parking namespace, and there are no resources deployed into this namespace. Now let's try to deploy a workload into the current namespace for the first cluster. As you can see, the deployment was blocked because it violated the policy that we just created, which is now enforced across both clusters. Now let's try the same deployment on the other cluster. Again, the deployment has been blocked. So clearly, the policy enforcement at deploy time is doing exactly what we specified and enforced within ACS, and they're being applied to both clusters. And so now, if we wish to disable enforcement of the policy and allow deployments into the no parking namespace, we can modify the policy by turning off the deployment time enforcement. Let's go ahead and do that. So we'll go ahead and click on the policy. Let's click and edit. Click next, next, and next. And then we'll switch deploy time enforcement to off, and then we'll save it. And so now the policy is no longer being enforced, and we can try to attempt those deployments again. So let's go ahead and do that with the first one. And there we see that our pod has been created. We can verify it. And we see that the pod is running. And we'll do the same thing in the next cluster. And there again, we see that the pod was created. And we'll verify that the pod exists. And there we have it. There's our test pod deployed in both clusters. In this video, we covered DevSecOps and pipeline strategies to help you secure your workloads. We started off with an overview of DevSecOps, and then we jumped into pipeline strategies. There we began with the basic pipeline and then gradually built our way up by adding more pipeline stages, and then integrating GitOps, and then finally integrating security-related stages to our pipeline. I hope you were able to learn from me and walk away with some additional knowledge in your pocket on DevOps and DevSecOps. Feel free to ask questions and leave comments in the comment section below, and do hit the like button if you'd like to see more content like this in the future. Thank you all.